the deadline?
At 11 o'clock today.
Okay. I'm asking why. Just a second. I want to share my screen and I want to. Okay.
Professor, I have a question about the last question on the lab report.
Wait a second. I'm just making sure what I'm doing. Okay. Yes, I want us to do this. So I'm recording the session now and I want us to open lab 4 to discuss your questions. Okay. So this is lab 4. It's gonna open in a moment.
Professor, I have a question.
Just say
Professor Jessie.
Yeah, Miss Jessie. Yeah. Okay. So this is lab 4. So
Okay.
basically,
about the lab.
yeah. What's wrong with lab 4? Go ahead. You can ask.
I have a question about the last question about lab report and about the graph. To graph it, I'm not knowing like how to graph it, like the incline.
All right, like here, they want you to compare and comment, deduce, add. Like here, they want you only to do the average and the RMS. There's no need to do any plot. Are you discussing number 6, Nazir?
Oh, yes, it was number 6.
Okay, number 6,
to draw a sketch.
They want you to come up with an experiment. It's a thought experiment you come up with to be able to prove that the acceleration and the mass are dependent. You know, the heavier the object, the slower the acceleration is, the lower the acceleration is, the smaller the acceleration is. Can you try to prove it through an experiment? You see? So probably you want to try to tell me what the experiment is. Yeah, so start by listing the material needed, start by writing the procedure. Maybe you want to draw a sketch of the setup, like a cart and an incline, some masses. Just draw them on a piece of paper. And eventually you have to explain using Newton's second law how the mass depends on the acceleration. You see?
Okay. You have to put F equals ma by using this formula.
And then you show what is the F on your system, what's the mass on the system, and how the acceleration is affected. In this experiment, the mass cancels out. Do you remember? What we did was the following. I remember we did, and Carl was helping me. This is what I remember. We did net force is equal to ma, right? And the net force
G sin theta.
Yeah, the net force is mg sine theta. So you ended up with mg sine theta is equal to ma. And this is where the mass will cancel out. But usually the mass does not cancel out. Only in free fall and in an incline, it does cancel out. So now they want you to devise a procedure to show that it does not cancel out. Like it's dependent on the mass. Any experiment would work. Just list the equipment and try to discuss Newton's second law. What is the net force? And probably you will end up with some results, okay? Any other question related to lab 4? Yes?
For the error on the average.
Yes.
It can be written in a scientific notation.
All right, the error on the average is very important to discuss. And so let me write it down. The error on the average, can you see my screen? Is called the RMS error, okay? And it must be rounded to one significant figure only. So it doesn't have to be scientific notation. All right, so scientific notation or not is okay. By the way, I corrected some lab reports and I would want to share some mistakes with you. I believe it's very important. This is your class. Carl, it was yours probably. Lab 3. Yes, in lab 3 you have RMS. Do you mind if I share some of your mistakes, or not really your mistakes, probably your good answers? Okay, do you mind, Mark? I mean, Carl?
No, I don't.
Okay, let me see. I just opened it. What happened? Okay, it's here. Oh, this is projectile motion. Initially, I wanted free fall. So free fall is lab 2. Give me a moment. By the way, I'm not at home. If for some reason you believe I'm glitching, it's probably the Wi-Fi. So I have no idea how the Wi-Fi is gonna be today. I had to leave home, and you can see that I'm having difficulty. Okay, opening this. It's a bit slow, bear with me. As long as I'm not glitching, I'm okay. By the way, I wanted to show you something, Carl. And now I'm grading each student alone, so you will have lab 1, 2, 3, 4 in one shot. Okay, expect your grade is gonna happen soon. So look at those Excel sheets, Carl. I know they look so nice, but you see how they look like on my screen? Like I can see part of the graph and the other part is on a different page. You see how awful it is? I tried my best to try to guess what's inside.
Doctor, your screen is freezing.
Say it again. What did you say, Mark?
Yes, now we can see your screen. It was freezing.
Yeah, I think my internet connection. This is what I was scared from. Okay, anyway, what I want us to check is the document, not the Excel. Let me know whenever my screen is frozen, okay? All right, look at Carl. He did some very nice work. Okay, so the average is this, and the RMS is this. Do you see it? He rounded. By the way, how come you rounded? Okay, this is a mistake here. How come you round 1.7 to 0.2? Probably you meant 2, or was it 0.17? I need to check this out. Can you please explain, Carl, what happened in this one? Carl, can you hear me? Hello,
Yes.
Joseph. So, Carl, can you please explain?
I'm looking to see what happened.
I don't think the error is 1.7, or probably it is, because look, from 6 to 9 to 9. Are you sure this is 6? Because I don't remember giving you values that would give you a slope equal to 6. But it's okay. Probably you have a mistake on this level. And probably, so here you have to round your RMS to 2, not 0.2. Okay? So probably I can write it down. Wait a bit. Let me grab a pen. Okay. And I'm gonna say, in this case, and I would love everyone to hear this out, the RMS is equal to 1.7. This should be rounded to 1/6, so I'm gonna write it as 2 meters per second squared. And now my average should have the same number of decimals as the RMS. Must have the same number of decimals as the RMS. How many decimals the RMS has? How many decimals this number has?
1.
None, nothing, no decimals. Okay, so I'm gonna simply write 8.5 must be rounded to 8 meters per second squared. But don't worry, because probably Carl has a mistake in the slope anyway. So this is not what the RMS should be. All right, but it's okay. Calculation mistakes happen. So always round your RMS to 1/6, and then make sure you round the average to the same number of decimals. Like here, I wrote excellent analysis because I saw 0.2, it's 1/6, and then 1 decimal, I thought it was perfect. But I did not see the 1.7. 1.7 cannot be rounded to 0.2. It has to be rounded to 2. You see the mistake that Mark did? Anyway, now back to this one. Do you still have any questions related to lab 4? Please ask. It's our time to discuss it.
I have a small
Yes.
question.
Yes, go ahead. Go ahead, Leah.
Okay, when you put plus or minus for the mass of the card, what are we supposed to?
Excellent
Right.
question. Nazih asked me this question this afternoon. So the mass of the card. I want you to go back to the video. In the video, I explained that the card was measured, the mass of the card was measured using a balance. It was a digital balance. And I gave you the value of the mass of the card. That is a bit different than this one because probably this is a different card. And you know, we have 8 cards in the lab, each of which has a slightly different measurement for mass. But I said it's a digital measuring tool. What is the smallest subdivision if you look at this one? What is the smallest subdivision you can measure using this balance? Can you guess? Yes, Leah?
0.01.
Yes, it is 0.01. Because the smallest digit is this one, right? And it's your second decimal. And this is the smallest subdivision. So how can I write it as a note? If the measuring tool, and this is very important, if the measuring tool is digital, the error is the smallest subdivision. And if the measuring tool is not digital, so what do you say? The error is, you tell me. The smallest subdivision.
The smallest subdivision divided by 2.
Divided by 2. Thank you so much, Kar. Imagine you being absent from my class. It's not the same. Look at you. You're helping me a lot. So this note is very important. How about you take a screenshot? So if the measuring tool is digital, the error is the smallest subdivision. And let me underline it. And if the measuring tool is not digital, the error is the smallest subdivision divided by 2. And this would lead me to the incline, to the angle. How did I measure the angle? I used the protractor, right? And the protractor is not a digital measuring tool. It's an analog measuring tool. And I told you in the video what is the smallest subdivision. Watch the video again and pause where I discuss the protractor, and it will tell you what is the smallest subdivision, okay? It's basically easy. Fine. How do you find this error? This is complicated. How do you find this one?
Okay, thank you.
This is tough. How do you find a theoretical? Maybe give you some time to think about it.
Professor, A theoretical is G sin theta. G sin theta.
Okay, and how do you find the error on A theoretical?
You have to put a percent of error, theoretical minus experimental over theoretical times 100.
This is not the percentage difference. It's called the uncertainty.
Oh, right.
Okay. You look for uncertainty. Let me see if I can insert. I want to insert a text box. Where is it? Where it's
you use propagation of error.
Yes, thank you so much. Okay, I need to insert a text box. What happened? What happened? Okay, it took the whole thing in a text box. Let me undo. Okay, text box. Can I insert it here? No, it doesn't allow me. Why? Okay, what just happened? I think because my computer is acting slow. Okay, no problem. I can simply type it. Let me type it in here. I'm gonna say to find the error on A theoretical. So A theoretical. Say it again. What was the method? Use the
you have to find the propagation of error.
Propagation of error. Okay. What is the error on G? Is it given? I don't think so. So you don't know what the error on G. You only need to do the error on theta. I need to give you a hint. Please use radians and not degrees. Do you know how to change everything to radians? I mean by everything theta. Theta, if you can change your theta to degrees and change the error on theta to, to radians, and change the error on theta to radians while you do the propagation of error. Because the degrees is not a real unit, you know, the radians is the SI unit for angle. Otherwise, you will end up with a very big error on the acceleration that doesn't make sense. Okay? So as a hint, while you do the propagation of error, I want you please to convert degrees to radians. That's very important. Okay? More questions. Thank you, Leia. You just asked a very interesting question. Any other questions? Yes? All right. Shall we move to lab number 5?
No, thank you. Pass.
Okay. Joseph, how are you today? I need to talk to Joseph, to Michelle, while I open lab.
I am good, doctor.
You're good? Okay. How about Michelle?
Yes.
You're okay? Are you working on lab 5, on lab 4, I mean?
Yes.
Are you ready to submit it this evening? Yes? All right, you guys. So lab 5 is about forces.
Before I joined, I slept.
All right. You already submitted your work before you joined. This is what I heard. Awesome, actually. All right. So you will be given a table. I will show you in the video, on which you have 3 different pulleys, okay, attached to the table. And then you have a wire, you have a mass, another wire, a mass. I was hoping to see Dana. Yes, Dana. She's absent today. And another wire with masses. Like you have 3 different forces. And inside, in here, you don't actually see it, but you will see it in the video. You have a small ring that is transparent. The purpose is to make sure the ring is in the center, it's in the middle. So you're gonna create force 1, 2, and 3 and make sure the ring is at equilibrium. In other words, you want to make sure that sigma F is equal to 0. I love this experiment. It's all about equilibrium and it has a lot of geometry, okay? How do you, okay, let's say you have F1 and F2 given. How do you believe F3? Let me draw F1 and F2. So I'm gonna use a green pen. This is F1, okay? And this is F2. How do you believe F3 should be to cancel F1 and F2? Any idea? I want you please to speak up. How do you believe F3 should be to cancel F1 and F2? Anyone?
It has to be opposite direction and it will be negative.
Okay, so what Nazi is trying to say. Exactly, this is what Nazi meant. You actually have to have F3 equal and opposite to the resultant of these two. Now we need to learn how to find the resultant, okay? It's very easy to do it experimentally because you simply have to move F3 right and left and add more masses to your hanging mass and make sure the ring is in the middle, you know? So experimentally, you can easily guess by trial and error. And unfortunately, I'm gonna do the experimental part and give you the values. You just need to do the theoretical part. Hello, Fadi. May I speak to Fadi, please?
Hi, doctor. Yeah, sorry for being late.
No, it's okay. I'm very
Really
happy
sorry.
that you are with us. Being late is much better than being absent, you know? Fadi, are you okay with lab 1, 2, 3?
I'm sorry for the last week's, doctor. I was... Naam?
Are you okay with lab 1, 2, 3? I'm still waiting for you to submit.
Yeah.
Okay. Fadi, speak to me if you need help, okay? I'm willing to help.
Okay, sure.
Just imagine I'm your tutor and I can do it for free. Okay?
Okay, sure. Thank you.
Let's do that.
Okay.
So now I need to discuss the fact on how to find a resultant theoretically. Okay? So I don't want to look at all this crap because it sounds a little bit difficult. How about I create some space for us and I give you an example, okay? And the example is the following. Probably use a grid line because it may make your life so much easier. Let's say I have this force that I'm gonna call F1. You have the magnitude of F1 and you are given the magnitude of F2. I need someone to help me guess the resultant of F1 and F2. How do you find the resultant? Anyone? Yes?
We just make a parallel line from F1, parallel line of F2 on F1.
Okay.
And the same on the.
All right. And this is the resultant. And then do you measure it with a ruler? Okay, so the first method is called the graphical
do it from the triangle.
Yeah, so the graphical method, is that what you mean? Did I understand right?
Yes, I guess.
Okay, so the graphical method or the parallelogram method, yeah? So you actually need, what do you need? You need a ruler to measure the resultant, right? Resultant. And you need a protractor and a protractor to measure the angle. Any angle you want, but basically I would want to measure this angle because I need to tell how the resultant R is actually pointing, in which direction. Any other method you can think of?
هيدي تبعت اللي عندها 90 degrees.
So the 90 degrees, what is it? Anyone can help Joseph? It is a right angle triangle. This is what Joseph is trying to say.
Yeah, but I forgot the name of
Can you explain how we do it? To find R, what do I do? Do you remember?
F2 R times F1 square.
Exactly. So you do the square root of F1 squared plus F2 squared, right? This is called, do you know the name for it? Anyone?
Pythagoras.
Exactly, the Pythagorean method. We call it the Pythagorean method or Pythagore, whatever you want to call it. All right, any other method you can think of? I'm gonna call this the algebraic method. Algebraic meaning the calculation method. Algebraic method, or whatever you wanna call it, the calculation method, okay? Can you think of a third method that is also graphical? I'm gonna call it the tip to tail method, okay? I find it easier than the parallelogram method because it requires less estimation. So I draw F1 and then on top of F1 I draw F2. So we call it tip to tail. So this is F1 and this is F2. By the way, you can drag F2 anywhere you want as long as it's parallel to itself. And then I can simply join the tail and the tip to find the resultant R. This method is nice because when you have an angle that is not 90 degrees, drawing the parallel lines will induce a lot of errors. And you will see the graphical method, this one and this one, will not give you exactly the same answer, but answers that are basically close to each other. So I don't trust the parallelogram method. I think the tip to tail is still not precise, but it's a little bit more precise than the parallelogram method, okay? All right, now I'm gonna give you another example without the 90 degrees to see how you guys are gonna think about it. And I love this because the lab is basically over. I'm gonna give you all these examples but you have to do a lot of work. Like you have probably 10 examples. You need to do the graphical method, one of your choice.
Doctor,
Yes. Yes.
you're not recording the session.
How do you know it's recording in here? I'm not using WebEx. I'm using Zoom to record. It's not recording.
Oh, okay.
Well, it is recording.
Oh.
You know, WebEx would give me very big files, and it takes me forever to upload to YouTube and takes you forever to check on. You know, Zoom for some reason is giving me very tiny files, and I like it. I know it's creepy to open 2 apps, and that's why my computer is slow at some point, or my Wi-Fi is not handling it. I'm sorry for that, but it's much better for recording, okay? But keep an eye on this dot. If I'm not sharing or anything, let me know. All right, now how do you find the resultant in this case? I suppose the tip to tail method is easy, the parallelogram method is easy. How do you do the algebraic method? Anyone?
You have to add them only. You have to add them.
Like, let's say I have 2 newtons, and I have 3 newtons, and I have 20 degrees. How do you find the resultant by calculation? Who knows?
It'd be AB sin theta. AB sin theta.
So we break down all the vectors into components, right? Do you hate this method? Okay, let me try to do it together, okay? So I'm gonna show you the X and Y axis. So this is my X axis, okay? X axis, and this is my Y axis. And I want to break each force into 2 components. So I need some help. Someone with a calculator. Anyone has a calculator? I think I do, because give me a second. This is my calculator. And please do the calculation with me. I need help. Probably Fadi can help me as well. Fadi, are you still online? So I need F1x and F1y. Yes. Then I need F2x and F2y. And then I need the resultant x and then the resultant y. And then I need R and the angle, total angle. Let me call it total angle or angle of R. Okay? It sounds time consuming, but it's okay. I have no other choice to do the algebraic method. All right. Probably ask Leah to speak up.
Yes.
Leah, what is the x component of F1?
It's 2 newtons.
2 newtons. What is the y component of F1? So F1 is on the x-axis. It does not have a shadow on the y. It has a shadow on the x only. So can I say it's 0 newtons?
Fine.
Okay. I need
Can
to...
we do it?
Yeah.
Sine F2 sine 60, cosine 60.
Why 60?
Sorry, cosine 70.
Listen, for F1, since F1 is already on the x-axis...
Okay. Sorry,
yeah.
sorry.
No, no,
F1y. Okay,
yeah, you're okay, you're fine. Since F1 is already on the x-axis, I'm gonna take the x component of it to be 2 and the y component of it to be 0. I'm gonna ask Rima to help me out with F2. You see, F2 is at a certain angle. I know that probably each one of you has a different method, and I don't want to confuse you. For me, I can think of 2 methods. What is Rima's method? Rima, how do you find the x and y component of F2?
I think for F2 along X,
yes,
we don't have.
No, this is F2. So F2 is the one with an angle. I'm sorry for the background noise, by the way.
So can we do it like F2 sine theta?
Yes. So one of which will be F2 sine theta, F2 times sine angle, and one would be F2 cosine angle. But which is which? Which is which? Which one is for the X?
For the X, it's cosine. Yes. And for the Y, it's sine.
Okay, so I'm gonna take this one and keep it for the X. And I'm gonna take this one and keep it for the Y. Can you explain why? How do you know? Do you have any method you follow? Or you simply know it's always cosine for the X and always cosine for the Y? A sine for the Y.
Yeah.
Okay. So if you always use the angle with the X-axis, you can take always cosine for the X and always sine for the Y. Okay? Now I need some answers and I need you to help me with your calculator. I'm gonna say 3 times cosine 20 equals, and here I have 3 times sine 20 is equal. Answers, please. Make sure your calculators are on degrees.
Can you hear me?
For f
no,
of
I
x,
cannot
it's
hear you.
2.81.
Who was talking to me a few minutes ago?
2.81.
Yeah, 2.81 newtons.
Yes.
And this one?
1.02.
1.02 newtons. All right, so I would want you to check the final answer. Is it positive? Do you see that this one is pointing to the right, the X component, and the Y component is pointing up? So both are positive, right?
It could be correct. It's positive. Correct.
Yeah. Yeah, both are positive. Thank you, Joseph, for the chat. Leia, we cannot hear you. We heard you a few minutes ago and you disappeared. So back to this one. If you always take the angle with the positive axis of X, you don't have to worry about plus and minus, but always check at the end if they make sense or not, okay? By the way, since you are asked to do the graphical method and the algebraic method, you can compare your answers, okay? Please don't be too lazy and not compare the answers. The graphical method should give you something reasonable but not precise. And if the algebraic method would give you something wrong, please fix it and check it again. And please meet with me at any moment if you believe you don't know how to break down the forces into components. Now I'm gonna ask Joseph. Joseph, are you with me? Yes, I can see you're unmuted. I cannot hear you. Probably Carl can speak up.
Yes, doctor.
Okay.
Can you hear me?
Yes, I can hear you. Carl, how do you find our X? Now that you have the X component of F1 and the X component of F2, how do you find the X component of R being the resultant?
The square root?
No, we simply add all the X together. Okay? And to find the Y component of R, I'm going to add all the Y components together. Okay? All the Y can you help me do that on your calculator?
4.81.
So this is 4.81 newtons, and this one is going to be
1.02.
Okay, awesome. And now how do you find R? Knowing that you
Now we do
have
the square.
exactly. So you are given Rx and you are given Ry. Now you can do the Pythagorean method to find your resultant. So I'm gonna say it's the square root of 4.81 squared plus 1.02 squared. Okay? What is the final answer?
0.91.
0.91 Newton. All right, now.
No, 4.91.
Yes, 4.91. Now, how do we find the angle? Any idea? So probably draw a better drawing and probably use the drawing to try to guess the angle needed. Okay, So again, this is our x.
Oh, Professor.
Yeah, Habibi, Jesse.
I know how to find the angle.
Yes. How do you find the angle? So
Jesse. Sorry,
yes.
sorry.
You guys, you just have to know that Nazir is talking to me every single day, and he's always like, Professor. Just call me Jesse. Come on, I'm your lab instructor. Okay. So just a second, I need to show you R. So this is R.
Jesse.
Yes, Habib. Yeah. And this is the angle I want. So you can call it theta if you want. Yes. How do you find it? So how do you do it?
You put AB sin theta. Correct?
You can do that.
The vector of R times Rx sin theta. The angle between the vectors.
Okay, why not?
A times B sin theta.
You're saying that sin theta is equal to opposite, right? Which is Ry, divided by hypotenuse, which is R. You are given R, you are given Ry, you find theta, right? Yes, do that. Why not? I'm happy with this one. Okay, you can use cosine as well, you can use tangent as well, anything you want. Just remember SOHCAHTOA. And what I mean by SOHCAHTOA, just make sure you know that sine is opposite over height, cosine is adjacent over height, and tangent is opposite over adjacent. Tangent is opposite over adjacent, yes. Usually I use tangent because I have Rx and Ry, and I don't like to use R, but yes, what you just said, Nazir, is not wrong. Okay, now let me show you what they want in the lab report. They give you mass 1 and mass 2. This is mass 1, it's here. Let me show you mass 1. This is mass 1. So how do you find force 1? If you are given mass 1, how do you find force 1? Probably Fadi can help us, or Michelle. Yes? Michelle? Leah, Rima, Joseph. Michelle is unmuted, he's trying to talk. Probably my internet connection. Probably try again with Carl.
Yes, doctor.
All right, so Carl, if you are given M, the mass of this guy, how do you find F1?
F equals MA.
It's basically mg. Remember, this is equilibrium, no
mg, yes.
Okay, so I will take m1 and multiply by g. What do you want to take g equal to?
9.81.
Okay, let's take g to be 9.81 meter per second squared, and the mass should be in grams or kilograms?
Kilogram.
Yeah, that's very important. So again, what they do is the following. I want you to go back down and check the table. They actually give you the mass in grams, so make sure you convert to kilograms, and they give you the angle on the figure above. I'll show you again. Your job is to find F1 first, then F2, and draw them according to the angle, and find F3. Remember, F3 is equal to minus resultant. So probably find the resultant first and deduce F3. Let me show you the angles again. I hope they're visible in here. Okay, they're not visible. I'm gonna show you in the video in a moment. But before I move to the video, they want you to deduce F3. No, this is something I will have to fill in. So I will give you mass 3. You calculate F3 being m times g. How do you find the angle? I give you the angle because this is experimental and I do the experimental method. Now for the component, the theoretical method, you have the component method. So you break F1 into components, you break F2 into components, you break F3 into components. Actually, you find F3, which is minus the resultant, and you find the angle, and you show all the calculations you're supposed to do on a paper. And the graphical method, you do it on a paper and you show me a picture of your work because you need to draw F1, draw F2, do the tip to tail method to find F3, and use a protractor to find the angle. Yes.
We have to do it 6 times or only 1 time?
No,
our
6 times. 6 times. For the component method, you need to break it down and somewhere on a paper. Okay? I know it's time consuming, but you have nothing else to do. And you have a week, you know? I'm sorry for that, but yes, you have to do all the 6 trials. Now let me show you the video quickly. I'm not gonna show you the video as is, but scroll through it. This is the table. In this part, you're gonna see me trying to show you the wire I'm using and show you the pulleys and how to put the connections and to show you the ring in the middle and the masses. That's video 1, but I will compile them into one single video. In this one, I already attached the wires. I explain how the masses are and how the forces are, okay? And I'm adding some forces and I'm showing you the plastic ring in the center. Video number 3 is the most important one because it shows you the table very well. So when I say the angle is 0, it means you put force 1 in this direction. When I say the angle is 210, it means I take this direction. So make sure you draw this on the paper when you do the graphical method. And this is for 3. Like here, you don't have equilibrium because the plastic ring is displaced a bit. I want you to see how the plastic ring is actually being displaced. So I fix this to 0. I fix this to 210. And force 3 should be found experimentally. Okay? I'm showing you how. Do you see the plastic ring, or it's not visible because it's transparent? Okay, it's moving a bit. And my job is to find the equilibrium position by moving the 3rd pulley right and left. It takes me around 5 minutes to find it, you know? You're lucky I'm gonna do the work for you. You just need to do the calculation. This is equilibrium. Let me show you the equilibrium. I will show you how many grams, and you can see the angle on the figure, right? And please use this picture. You can take a screenshot and draw on it. Like put the angles on it to do the graphical method. Yes, I'm ready for your questions. Do you think this can be done? Is it difficult? It's a bit tough.
Jessie,
Yes.
Jessie.
Yes.
About the equilibrium, you have to cancel the forces. You cancel the forces.
So you would say F3 is equal to minus resultant. Okay, let me take a screenshot and probably draw on it. So let me take this screenshot. It should be somewhere here. Let me wait a bit. Okay, what just happened? If I put this down and do this, this is the screenshot I'm looking for. So, and probably draw on it this. This is F1. Do you agree? Let me make it straight. This is F1. This is F2. And this is F3, right? F3 is equal to the minus resultant. And the resultant, if I do the parallelogram method, is, wait a second, probably this. Wait a second, I'm trying to do the parallelogram method. So F3 is somewhere here, you know? This is not precise at all. I need a ruler. So so the resultant, if I call this one R, this one is F3. So F3 should be in such a way to be equal and opposite to R. So F3 should be a little bit shorter probably. So it has to be a little bit shorter to be equal and opposite to R. You see? Yes.
So it will cancel each other. It will cancel each other.
Yes. R is the resultant of F1 and F2. And F3 should be opposite to R. So if you know the length of R, you can tell the length of F3. Okay? And if you know the angle of R, you can guess the angle of F3. Now the angle is a little bit tricky because we're doing 360 degrees, but on a paper, it's gonna be all right. Okay? You don't have to guess, just draw it on a paper. All right, you guys, any other question? I want you please to meet with me throughout the week whenever you are facing any difficulty, okay? Remember, I'm your tutor for free, so don't ask anybody to help you. As long as Jessie is here, she's ready to meet with you anytime you decide. Just give me a day and time and I can meet with you online. Cool? And let's call it office hours. I'm ready for your questions, otherwise you are dismissed.